So my last topic in second unit, digital Fourier analyzer. Digital Fourier analyzer. Here, one drawback for previous systems, that is if we want to analyze the data, if I want to analyze the data, please wait for 1 minute. Okay. For example, this is analog information. So previously I am connected it to a display system for measurement. If is there any modifications required in this information, if is there any modifications required in this analog information which is not entertained by normal display systems. Normal display systems. For example, in this digital information, it includes in this analog information, it includes, for example, noise. Only up to previous you have to increase using amplifier, otherwise you have to decrease using attenuator. These two things are only possible in previous analog information circuits. But this is, for example, I want to decrease noise. So there is no noise limiter circuits. I want to transform the form. I want to transform the form of the energy, which is not enabled in this circuit. I want to store in a particular location. That is not possible in analog information circuits. So now here we are using a digital Fourier transformer. That Fourier is nothing but the transforming from original to the next and next to the original. That is nothing but that Fourier. So digital Fourier analyzer, that means see here, all of you here, right side, this is my analog information. This is my analog information. If I want to modify this analog information, so this should be these modifications should be modified by a digital computer. So this digital computer is able to understand only the digital information. But the input here is Jyotirmayi. Kotte. Put your microphone. Yeah, okay. So it's a digital computer and it's a analog input. This analog input is not directly captured by this digital computer. That's why here we have analog to digital converter. In between these two, analog to digital converter. That means this analog to digital converter converts analog information into digital, and this digital information which is exactly equals to the analog, the same information. So this digital computer is able to transform the data. What the thing you are required, those things are done in this digital computer. If you want to suppress noise, if you want to store the data, if you want to change that one form to the another form, or if you want to increase or if you want to decrease, like that, the modifications, whatever it may be, which are defined by the user, those modifications done by this digital computer. Later here I am giving that digital information to digital to analog converter. Later we have a display system. The display system is nothing but, of course, a CRO. In that CRO we have two deflection plates, vertical deflecting plates and horizontal deflecting plates, nothing but for display. So this is vertical and this is horizontal lines we have, like that, for representing the voltages and current, voltages and time periods. So here voltage vertical and horizontal we have. So based on that we are giving digital to analog output to two deflecting plates. This is CRO. Of course, if you want to if you are confusing for this, just it's a digital computer to digital analog converter, and digital analog converter to direct CRO. No need of mentioning vertical and horizontal deflecting plates. If you are able to know this particular, why? Because this particular topic will be covered in the next unit of cathode ray oscilloscope, unit 3, cathode ray oscilloscope. If you are somewhat struggling for this, just you have to write it for this particular line only. No need to mention here the vertical input or like that. So digital computer to digital to analog converter and digital to analog converter to cathode ray oscilloscope. There is no need to mention to vertical input. If you have some awareness regarding this vertical and horizontal, of course any screen should be visualized by using some vertical and horizontal, just like the graph sheet. So vertical and horizontal, this is, that's why vertical deflection and horizontal deflection, these two deflections are must and should we are following. And previously in physics a subject also you are studied about two-dimensional motion of the electron. One dimensional is vertical and another dimension is horizontal. So that is also one of the reason for vertical and horizontal deflections. So finally here, see here, this is this is low pass filter, nothing but if you want to reduce the noise, if you want to get the accurate signal, this low pass filter is used, and this is analog information, and this is attenuator. From this attenuator to analog to digital converter, here the output is digital and here it is analog, and this is digital computer. This digital computer command over on analog to digital converter and attenuator. So this is only input, and this digital computer's command is on analog to digital converter and attenuator. That means this digital computer is able to control these attenuator and analog to digital converters. So here we are, if you want to modify, first thing is for here is memory. Previously we have studied about AWG, arbitrary waveform generator. There we have a digitalized memory, converting it into digital and then memory. So here this is digital computer. That means it have obviously memory. If you want to transform data, if you want to change the original, all those things are done by this digital computer. After here we are giving this to digital to analog converter, and this is the normalized cathode ray oscilloscope. That means here the main purpose of this digital Fourier analyzer is for data manipulation and data storage purpose. Data manipulation and data storage purpose. So this is nothing but a digital Fourier analyzer. Is it clear, all of you? Is it clear? Okay, thank you. Please note down this diagram. Here our intention is to change the data by using a digital computer. Here we are applying analog. This is analog. This is analog. That's why we need to convert that into digital. So this is digital computer. It has the first thing is memory. Second thing, data manipulations. Analog devices can't do this particular. That's why we are changing that into analog to digital, and we are using digital computer. And of course, it's a costliest one. Why? Because of using digital computer. Later, our purpose is solved here. Later, we are converting that digital into analog, and this is CRO. Completed? Completed? Okay. Please note down these points also. A spectrum analyzer which uses computer algorithm and an analog to digital conversion phenomena and produces spectrum of a signal applied as its input is known as digital Fourier or digital FFT or digital spectrum analyzer. Principle: when the analog signal to be analyzed is applied, the A to D converter digitizes the analog signal. That means analog signal transformation is not possible using digital computer. Example, that is, converts the analog signal into digital signal. The digitized signal, which is nothing but the set of digital numbers indicating the amplitude of the analog signal as a function of time, is stored. In the memory of the digital computer, from the stored digital data, the spectrum of the signal is computed by means of computer algorithm. Please note down this. This is nothing but simple principle what we are explained previously. Of course, it's a para, but here I am taking that as a number of points for the easiest understanding. The block arrangement of a digital Fourier analyzer is illustrated in the below figure. The analog signal is to be analyzed is applied to the low pass filter, which passes only low frequency signals and rejects high frequency spurious signals. The output of low pass filter is given to the attenuator. The attenuator is a voltage dividing network whose function is to set the input voltage to the level of the A to D converter. The function of A to D converter is to convert the samples of analog data into digital, that is to digitize the analog signal. కంప్లీటెడ్ మీరు ఓన్గానే రాయొచ్చు దీన్ని. Completed. When the output of analog to digital converter is applied to the digital computer, the computer analyzes. This is the most important point, and why we go for the digital Fourier analyzer. The computer analyzes the digitized data and adjusts the attenuator settings accordingly in order to obtain the maximum output from the inverter without any overloading. As soon as the entire analog signal is sampled and digitized by the analog to digital converter, computer performs calculations on the data according to the programmed algorithms, and the calculated spectrum components are stored in the memory of the computer. That means what type of program you are given for the digital computer, that program is performed using the programming algorithm. So if the spectral display is to be viewed on the oscilloscope, the digital values of spectral components stored in the computer memory are converted into analog by using digital to analog converter. That means when we are completed the complete operations on the digital computer, then only that spectral view of the oscilloscope will be available, and then applied to the CRO. Thus, the spectral display of the input waveform is obtained on the CRT screen. That means here in this circuit, input is analog, output is also analog, but in between we are using analog to digital converter and digital to analog converter. In between we are using some digital transformation of data, need to convert the some modifications by using a computer programmed algorithms. That means using some digital computer we are performing this particular modification. So this is nothing but a digital Fourier analyzer. Digital Fourier analyzer. Please make it fast. This particular line thing is the need of this digital Fourier analyzer. That means from here to here. Completed. Completed. Next one, advantages. The use of computer avoids most of the hardware circuitry such as electronic switches, filters and PLLs. The use of less hardware reduces the cost of the analyzer. More mathematical calculations can be carried out on the spectral display. The rate of sampling analog signal can be modified in order to obtain better spectral display. That means the main advantage is using computer. You can perform a lot using this particular device over number of analog devices. So these are the advantages of using digital Fourier analyzer. Please note down these three advantages. Completed. Next, distortions in transmission wave. Of course, this is the prerequisites for the next unit. Of course, we have 2 marks question like what are the different distortions in transmission wave. These 5 are the 5 distortions. See here, these first 3 is the basic distortions: amplitude, frequency, phase, along with crossover distortion, intermodulation, distortion. Crossover is nothing but one-to-one added. We know about amplitude, frequency and phase distortions, but this crossover distortion is nothing but a one-to-one added. That means one signal to other signal is added. So intermodulation, that is also during the modulation. Generally we know about the definition for a percent of modulation. In that percent of modulation, some rare dilutions in that modulation, nothing but we know about under modulation, perfect modulation and over modulation conditions. In this condition, if it is under modulation, then that modulating signal is not modulated 100%. That is nothing but that inter, which is suffers with the basic modulation conditions. That is nothing but intermodulation distortions. That means what are the main distortions in transmission line, not in the circuits. See here, in transmission line or transmission wave: amplitude, frequency, phase. We know about all these 3, but this crossover is nothing but this is one signal, and of course this is another signal. If these 2 signals get distorted in a single line, so this is nothing but crossover. So studied this particular in a CMC subject, that by means of crosstalk. You are heard this with the crosstalk in CMC, but here we have crossover, that nothing but one-to-one signal added. Intermodulation is nothing but some sort of deviation with the modulation. So this is nothing but unit 2, signal generators. And here I'm giving you one instruction, that is tomorrow we have CT1 on unit CT1 and unit 1 All of you please be prepared for that class test very effectively. Previously I am forwarded the material and the PPT also. After completion of this I am forwarding this PPT also, and this week we are completing the class test for this unit also, and only we have only one unit left, that is cathode ray oscilloscope. Actually our schedule of midone examination is June first week onwards. If you go through the academic calendar, it shows us the schedule of mid one is from June 1st onwards. If the mid examination is conducted or not, based on the instruction from the JNTUK, we are continuing the mid two syllabus. So that's why we are planning to complete the unit number 3 is also up before that first week. That means more we have 10 to 15 days. In these 10 to 15 days, we are completing that unit number 3 also very easily. That unit is also very easiest unit like this unit, but here the thing is number of circuits were studied. So please concentrate on that number of circuit. First unit is 2 parts. Likewise, for your understanding purpose, your understanding easily the first part and second part very easily, but in the second part the whole concentration on the signal generator only, the types of signal generators, number of signal generators we have studied. So for each and every signal generator have its own functional diagram. So please go to the functional diagram and just write the data related to that. That's it. There is no derivations here. There is no problems in this, and there is no bulk content in this. Of course, in first unit we have problems on errors and the problem definitions, error definitions. We have circuit diagrams. We have like that, but here we have there is no circuit diagrams. Only the diagrams are block diagrams only. Only the block diagrams. That is the thing. And here I am holding this unit. Any doubt in this unit, please respond. Any doubt, any topic in this unit? Please respond. Any doubt? Please respond. Any doubt? Now I am giving you the unit 1 quiz. So previously some of you are responded for this. One more time I am giving. At that time very few members are attempted this related on unit number 1. Now one more time I am giving this. All of you please go through this link and answer these questions. This is not for assessment. This is for your understanding. So don't go through any sites for searching the answers for these questions. Just check yourself. You are how much aware for those particular topics, those particular lines. Around 15 to 20 minutes for us. So in this time, just go through this very easily and please attempt that. Otherwise, meanwhile, if you have any doubt, please ask me now. All of you, please go through this link. "39 students are presented here. 39, 2, 3, 37. 37 students are presented here. One more time I'm repeating. Tomorrow we have CT1. Tomorrow we have CT1. 9 members submitted. Till now, 9 members submitted. See here your responses. Last 5 minutes. All of you, please make it fast. By exactly 10:40, holding that link. Last 2 minutes.
అదేలే. Good morning, sir.
Sir, good morning, sir, and nice to meet you, sir.
Okay, no camera for class test?
Yes, sir. Camera is also required, sir.
Encourage. Okay. They are uploading, right?
Yes, sir. Yes.
Okay, okay, sir.
So this is not class test, sir. It's a quiz.
Quiz, okay, very good, sir.
2 minutes, sir.
Sure, sure.
Last 1 minute, all of you. 25 members admitted. Last 1 minute.